So I'm here with Professor, now I have to be careful, Hironori Washizaki from Waseda University. I'm sorry for the poor pronunciation.
No problem.
He's also the organizer of the seminar that I'm attending here, which is about patterns and practices of AI engineering, which is a wonderful topic. So thank you very much for organizing it. It's really a pleasure to participate. Yeah. One of the key topics that came up a lot during the seminar, and I would like to understand from your perspective as well, is generative AI is having huge impact on software engineering. I think we can agree on that.
Yeah,
definitely. What do you see? What is your perspective?
Yeah, of course, there are a lot of impacts in the pros and cons, right? Of course, the pros are, of course, in generative AI is good for, increasing, of course, productivity, automation, and particularly for some very concrete tasks, such as coding or testing or removing defects. So those are kind of very, very concrete tasks and with quite less uncertainty.
Right.
Well, at the same time, generative AI is quite useful for exploration, right?
Right.
Particularly at the very early phase of such as, for example, we are adopting requirements in engineering.
Right.
AI and generative AI empower generative AI and requirements engineers. So, so often, requirements engineers don't know some potential, requirements or even some, context but the generative AI would suggest some potential areas or potential ideas so that's really good.
Very good. Excellent. Yes. So what I'm seeing is that you're talking about the entire software engineering lifecycle, from requirements to architecture design, to detailed design, to coding, to testing, to documentation, to release.
Right.
Is that you see generative AI playing a role in all those aspects, I believe?
I believe. However, of course, the reality is country. For example, I'm also somehow involved in the Japanese industry.
Right.
And in most cases, just very limited.
Limited use so far.
Basically coding or just little testing work. Because once again, because when engineers adopt generative AI for their task, they need to know what the correct answer.
Yes. Right. So that we don't go and trust too much in the generated output.
Exactly.
And what is the main reason that we cannot trust the output fully off? What are you seeing as the main reasons for that?
Well, there are a couple of reasons. Firstly, of course, still for some specific tasks, often generative AI is not so much good,
Right.
Having some very low performance, low accuracy for very specific, for general tasks, that's fine. Just making some documents but for very specific tasks, such as needing some domain knowledge or some special, very complicated specifications, and then often generative AI would make mistake. Therefore, engineers do not trust so much. Maybe that's one thing. But also, that's a kind of missing trust. Okay, even if generative AI, produces really good, code or really good, document or really good test cases.
Right.
But still, well, right now, so far, engineers do not so much trust.
Right. So that is, I think, the trust. And you think, will they start to trust more in the future over time?
Yeah, I think so. Well, actually, my team, particularly one of my students, has really done a really good job about. There is a very famous paper, if I remember correctly, made by the Ahmed Hassan's group.
Okay.
And they discovered that pull requests made by AI agents have quite low approval rate. Compared with pull requests made by human.
Right.
But then my team examined what's the reason of such very low approval rate of pull requests generated by agents. And the main reason was not technical issue. Well, at the beginning we thought that, maybe technical issue because, generative AI would make mistake. But actually, main reason was not. And actually, the other side, still we are country continuing investigating. But we see that pull requests pulled by generated by agents, often approved by human. When human experts, human engineers, were somehow in the loop.
Right.
So that implies that. So
we need human and agents to work together.
Interaction is the key to increase more kind of trust between AI agents and human engineers. Otherwise, AI agents, recommend this, pull request or dispatch, and all right, that's it. It doesn't work so much.
That didn't work so well at this point in your companies. If I was a young software engineering professional just coming out of master's program or something like that, what would you recommend to a young, newly started software engineer at this point?
Because read Bosch guide, software engineering body of knowledge. Yes, of course. Of course, you know that. Okay.
Yes.
In these years, I have read evolution of Bosch guide, IEEE Comp Society's software engineering body of knowledge. Okay. Well, because, as I said, generative AI can make mistake. So more and more we are relying on the generation with generative AI. Then engineers need to know what is the correct outcome, what is the correct way, what is the correct method, what is the correct process in software engineering. Therefore, students and also early career professionals should know what is software engineering. From requirements engineering to construction, testing, and even management. And after that, then they can utilize generative AI for some specific tasks. And I envision that in the future, each software engineer would be a manager.
Of a set of agents.
Exactly. Maybe hundreds of AI agents. And they just, make some documents, texturize what kind of task and then distribute task. And then I examine the outcomes.
So you really feel that having a good basic knowledge of everything in software engineering is going to be critical in the future as well.
Exactly.
So if we go to software engineering research, if I would be a young, freshly graduated PhD student and I want to stay in academic research in software engineering or in AI engineering, what would you recommend your younger self if you just came out of a PhD program at this point in time?
Wow, that's a really interesting question because at the beginning we often try to kind of do a kind of research about a kind of just extension, the extension of the existing thing, right? Okay, here's for example program repair. Program repair is doing good. Okay, so what about generative AI base or the kind of an extension?
So it's more evolution instead of anything.
Exactly.
Yes. Yeah.
So, but I think at the beginning, we may do so. But then what could be beyond such an existing extension of the current research? That is always a challenge. But and particularly new researchers or even students may come up sometimes really crazy idea.
Right. So I have one colleague who made a statement after a workshop that said complexity is for AI, creativity is for humans. Is that something you would agree with?
That's like that. Yeah.
Yes, because that's what I thought I heard you say, that we, especially in research, should not just continue on the work that we've been doing in the past, evolutionary, but rather focus more on the revolution. Is that what I heard you say?
Exactly. So sometimes we think about, what could be totally different. For example, I remember that as some researchers say, what if we can think about human as AI?
Yes.
Human as a robot, for example.
Yes.
Then what could be different?
Yes.
Maybe same or maybe different.
Yes.
Like that. I think I recommend that particular students or young researchers, you need to think about what could be different.
Right. As a final question, we all are part of a community. We, as a community, we often share a lot of thoughts.
Yeah.
What is one thing that you believe that others in the community do not believe or are not convinced of? What is one unique thing that you believe that others do not?
Maybe I would say a kind of somehow a kind of interdisciplinary aspect. Because maybe it could be somehow a nature of software engineering.
That we start to become more cross-disciplinary.
Exactly, because software sometimes, particularly for computer science students, software looks like just a problem, just a very kind of logical expression. And however, actual software engineering is different. Okay,
you need the domain knowledge.
Exactly, domain, business, some kind of culture aspects, and at the same time, of course, AI, data, security, and of course, you are leading that. But imagine that all businesses are moving towards software-centered or software-intensive. So then, software engineering should be much more multidisciplinary. So that is a very exciting aspect of this perhaps community. And indeed, this Shona meeting as well, having from different disciplines, different expertise. So maybe that's why I really enjoyed this as a part of this community.
Excellent. Good. And with that, I would like to thank you very, very much. I really appreciate you taking the time. Wonderful.
Thank you so much.